ga zo langzaam aan een beetje opstarten. Nou, van harte welkom bij dit webinar van de Nationale Coalitie Duurzame Digitalisering. Voor degenen die mij nog niet kennen, ik ben Hanna, ik ben programmacoördinator bij de NCDD. En we gaan vandaag in op de milieu-impact van data en bieden ook handelingsperspectieven om te kijken hoe we die milieu-impact kunnen verminderen. Dan gaan we even door naar de volgende slide, denk ik. Jawel.
And I think we do it in English.
We should do it in English. Yeah.
All right. Well, for everybody who doesn't speak Dutch and is really eager to hear my introduction in English, my name is Hanna. I'm program coordinator for the Coalition of Sustainable Digitization. And today we dive into the environmental impact of data, and also we're going to look at perspectives on how to limit the environmental impact of data. And I'm really happy to introduce to you our speakers today. All participants of the coalition, Ronald Meijer from IBM, Pepijn van der Veen from ING, you would say in English then, and Gerrit Ouderkerken from NetApp. So floor is yours, guys.
Okay, are you going to do the table of the topics, Gerrit?
Yes, let me start with the pub quiz. So this is a table of contents. We are going to cover all the items currently on screen. But as a starter, I would like to introduce you to the dirty secret of data pub quiz. So I will share my screen and share my screen. Wow. Okay. Stop sharing. I was locked off.
Can people already navigate to the QR code, Gerrit?
Yes, if you share the QR code.
Then I will share my screen again. Until you're...
This is very, very strange, but no problem.
So please then open the link.
Purpose is in the when you scan the QR code. It's just a simple Microsoft Forms. So I hope hopefully everybody could access it. Bear with me. Always the corporate securities is always logging you out automatically if you apparently do something which is unuseful. Presenting a pub quiz. Yes. Still logging in.
Can people already fill it in, or?
Yes, it's no problem. You could, if you scan the QR code. Here it is.
So please start.
So I will now take over the screen as well. Share. No, which is this one, and the QR code is also over here. So not so many people joined already. Yes, here he comes. We'll wait till more people will join. And if you join, you could join the fun as well and win the book from Ronald Meijer, which is one of the speakers as well. His book is called Duurzame IT is geen illusie. It is in Dutch. Ronald, I think. Do you have an English version as well?
There is also an English version, but that's the first edition.
Okay.
And the second edition, which is a bit more extended, is so
Okay.
if you are English, no problem, but you get the first edition then.
Okay, great. Well, let's give people some 2 minutes to join. It's so much more fun if people join this quiz and wow. Okay. I was sharing. Not sure what happened. I was automatically logged off my own pub quiz. Let's start again.
I've submitted it, Gerrit, but I'm not going for the
Right.
prize, as you can imagine.
You have some
the
spares
answer.
left, I think.
You know the answers, right? So here it is again. Let me again share the screen and then we will start, right? So window, this one. Okay, here we go. The first question is, what proportion of the world's total electricity consumption is used by data centers? Well, already some answers, 13 responses submitted. Well, let's see what the correct answer is. With me is 2%. So 2% of the world's total electricity consumption is used by data centers. There are some reports, recent reports of McKinsey, where the total consumption in the US for data centers is 2 to 4%. And due to AI, this could increase to more than 10%. And mind you that the total electricity consumption in the EU country Ireland is already at 21%. So 1/5 of the total electricity consumption in Ireland is assigned to data centers. And this has also all to do with all the hyperscalers in Ireland. All right, let's go to the other question. As of 2024, what percentage of the world's electricity supply comes from renewable energy sources? Because, well, everybody thinks that that if it is electricity, then it could be green. Yes, but how much? The correct answer is the total worldwide mix is 35% is renewable. All right, then only 20% of the people was at the correct question, correct answer. The next question, in the realm of IT infrastructure, what share of the world's electricity consumption is attributed to data storage? That is 20%. And given the total growth of data due to AI, Gartner is expecting it will grow to 30%. So 1/3 of the total world's electricity consumption is attributed to data storage of the data center. All right. How much of the stored data is never accessed? And again, after its initial use, this type of data is often called dark data or single-use data. Actually, the answer is indeed 68%. We do have reports where more than 90% of the data is never used. So, well, we have to put a number on it. But so 2/3 of the data is never used again. So that's one big giant of waste. Last question. According to predictions for 2030, our totally globally stored data is reaching 1 yottabyte. This could be compared with, well, we have some answers. The correct answer is, we always say at NetApp, is 500 smartphones in the hands of each world citizen. This is the correct answer. So, and this all sums up that if you don't do it on a sustainable way, it is literally a waste, because with so much waste data, single-use data, dark data, this is not going anywhere. So that's the reason why we want to do data management on a sustainable way. And in this presentation, we will show you how. I will stop my sharing, and afterwards we will do we will see all your answers, and we share the winner. We share the book by Ronald Meijer.
Thanks a lot. Then I will take it over. I will share my screen again. So no login screen, so lucky today.
Great.
So if you look to the sustainable data lifecycle and the impact of data, that was already addressed by Gerrit, that we see an exponential growth in the impact of IT in general, of the consumption of power by data centers, and also a big part and a growing part of that is the data. So yeah, from that we need to have a strategy how we're going to cope with that. So if you look also at this, so the International Energy Agency says that they have published a report in 2024 that if you compare the power consumption of 2022 with one of the assumptions that they have, one of the forecasts that they have to 2026 is that it double, and that's so then we add the power consumption amount of equivalent of a country like Germany only for data centers, and a big part for that we all know that is because of the growth of Gen AI, and that is consuming a lot of power from processing, but also needs a lot of data. The data is the shape of the data, the less data you need, and that will also come back in our story. So we see more and more that we need to look at data from a sustainability perspective. So we need a strategy. So what we did, we used the model of DAMA. That is published in DMBOK. So to look at the whole life cycle of data, from planning to the whole to in the end disposal of data. I will go very shortly to the model. If you look at, I don't know who is familiar with data management in general, but DAMA is a well-known institute with a lot of different groups in different countries contributing to all kind of publications like DMBOK. It's a data management body of knowledge. That's quite a thick book. So if you want to read something on data management, I think there's also always an issue with a background, but then you can it's available in Dutch and in English, or also in both languages. And if you look at data, it has a footprint to the total life cycle. That is why we use this model. So you start with planning. How are you going to plan the systems and the whole design and managing the data, and also the data itself, like classifications. We will go into that, and in the process you create data, you store data, you use data, and also you enhance data through time. Because for instance, if you have a customer data, you will change that through time, or you will add additional data to it. In call centers, recordings and subscriptions and all that kind of stuff. And somewhere in time, when you don't need the data anymore, then you're going to dispose it. But sometimes, if you look at the dark data, the example of Gerrit, then it's sometimes even difficult, and a lot of discussions in organizations. What can we dispose? And does this have no value, this data? And for that, you need to have a well-defined classification strategy, but we will go into that a little bit later. So, for the people that understand Dutch, so you start with planning. If a good start is the half of the work. So one of the most important things, and it's also what we said about how we in our introduction, we need to create awareness. So all data that's been stored will, in the end, will consume energy, and will also have impact on physical stuff like disks and tapes and other kind of stuff. So that is also impact. So in planning, it's very important to try to avoid a lot of copies. And also a main takeaway is that it's very important to look at the type of technology that we use to store data and to process data. Then if you look at the design phase, it's very important when designing an IT solution or a specific data solution, that the right patterns are used, so that you think about compression compared to the use. That's always a balance, because if you use data a lot and you need to decompress it, so have some impact on consumption, but that's something to look at. But we also already said, try to avoid data duplication. Also look at from a storage perspective on where do you store your data, on which type of, some types of data consume more energy than other types of data. For instance, if you look at your email archive in Azure, that is on tape, and that is one of the storage types that consumes least of type of energy. And also look at usage of virtualization techniques, because that also helps to limit the need to duplicate your data. And from a data management perspective, it's very important to classify your data to enable a good strategy, for instance, on data retention. Because if you don't know what your data is based on the right metadata, then you will also have a lot of dark data within your solutions and within your organization, and that will not help. And I think it's also a thing already in the beginning of your design, think on the disposal. That will help a lot from performance of systems, and also help in the sizing of those systems. So that will also have a positive impact on sustainability. Ronald.
Yeah, thank you, Pepijn. So I think you clarified that this is very important at the start of your project, let's say, to really think first about, okay, what am I going to do in terms of planning? What do I really need? And in terms of design, how am I going to do that? By the way, if you have any questions or remarks, please put them in the chat so that we can monitor those and can have a discussion on it later on. Sorry. So, but then you did all the thinking work, and now you're really going to create the data. And one of the principles we said is use structured data over unstructured data, because it is much more efficient. And I have an example from a client that I worked with, and they had the idea of, okay, we have the data, the structured data in our system, and we send out a mail or a document to our clients. And the idea was, okay, you take the name and you have a kind of a document template, you put the specific client data in, and you send out the letter. And then the people start thinking about, but if you have to resend the letter, it may be a good idea to store it as a PDF in this case. So, and they start calculating the amount of storage required to have it stored in PDFs compared to the structured format, and it was about 72 times more space that was required. So 3 lessons from that. First of all, as you can imagine, it takes a lot of more space. Secondly, if you would like to send that letter again, you have to regenerate it if you don't store it in the PDF. So that is a little bit of, I would say, well, inconvenient. You have to do something. It's probably a little bit more work. And that's also a lot of times the case with thinking about sustainable aspects of data. Maybe you have to do a little bit more work, but compare that with the additional effort or the additional impact of sustainability by storing a lot of these things. Third lesson is that they said, well, it's a good idea because if we do the PDFs, that is legally required. And this is just one example, but you can hear a lot of these kind of excuses to make our lives more easy. Whether in this case, I mean, it was not really legally required. It just a little bit more work to regenerate it if you have to resend it again. So really think about this. This is just one example, but I think you can imagine about more examples, and we have a kind of tendency to store everything in the best quality format. So that's also a thing. Do you always need to have very high quality audio, high quality video? Good is good enough. So then you created the data, and apparently then you would like to use it also, or to store it. First of all, store it. First we have to store it. There's a very nice saying in English: everything has a place, and there is a place for everything. And that's, I think, also true for the data. In the previous example, where you have structured data, it will probably fit very nicely in a relational database management system. I have a client that also stores the document in the relational database management system. That is possible, but it is not very efficient. They're probably much more efficient to store it in an object store or something like that. So think about what is the technology. And I can understand you don't want to have every technology and everything, specifically if you are a small company, but select those and probably select multiple type of technologies that would fit the need of your data storage. Another example, Pepijn mentioned already in the beginning, think about storage tiering. If you are an organization that is large enough, you can afford to have multiple tiers. And storage tiering is the technology that you use to store your data. Flash storage is a kind of the tier 1 because you can access the data very, very quickly. And then you have the disk storage, it's usually kind of tier 2. It's cheaper, not per se energy efficient, even though there are a lot of developments also in that area. When you acquire spinning disks, there is a lot of technology available which is much more efficient than the old spinning disk, which are running in circles forever. And then a third tier could be tape storage. Tape is very well known for backup capabilities, but you can also implement tape as a storage tier. And of course, it takes longer to retrieve the data from there. So it probably takes 10, 20, 30 seconds before you have it. So you can't store everything there. But let's say for the customs, the Dutch Customs Department, 99% of the customs declaration is never being touched up again. So why would you put that in tier 1 or tier 2 storage? And of course, compress the data and use the right location to store your data. Not every location is the same in terms of energy efficiency. For example, if you store your data in Azure, look at different locations, Azure locations. Microsoft is publishing this information, so you can see a data center in Indonesia that is not that efficient as the data center in the US. So think about, okay, where do you store it? Where do you keep that? And then now you want to use it, of course. So you did it, you selected the data for a specific purpose. At least I hope so. Probably, as mentioned before, in let's say more than 60% of the cases, there is no purpose. So why did you keep it in the first place? So within the Dutch government, you need to be very aware about that you only use data that is legitimate for that specific purpose. So they call that doelbinding and proportionaliteit. So I'm not sure how to translate it in English, but that's at least the idea of only use what you really need. And well, we have a kind of tendency try to get as much as we can. And that is not only from the perspective of data storage a issue, but it's also because you are going to process that data. And if you have to process the data that you already knew that you will not use, there is no reason to retrieve that or to store that in the first place. Now, talking about processing, in the world of AI, as mentioned by Pepijn, there is really a need for all kinds of resources, like GPUs. So they are expensive, and they are also consuming a lot of energy. So think about, how can I best utilize these resources? So maybe during the day, you are using the models, you're doing inference, and then the GPUs are quite well occupied. But you are let's say, European company, you don't need the GPU resources during the night, at least not for inference. Maybe you can use them for training, because it is maybe not necessary to do the training during the day, but can shift it to the night. So get most of your resources, get these scarce resources being optimized as much as possible. And then you can also think about, how am I going to do that? The right coding, the right languages. One language is not the same as the other. So you can have there's a whole list of languages being published and how expensive they are. Let's say that if you use good old C++, that is quite efficient compared to things like Python, which is 80 times more expensive in terms of utilization, 80. So it's really something to think about. It's not saying that you should not use it. It's something to think about. Okay, now, then you're using the data, you're doing that in an optimized way, but then you start thinking, well, there are changes. So I have to enhance my data. Different ideas, different principles relate to that. First of all, you can say, okay, let's only store the deltas. So I get new data, and I don't want to completely update it, but only keep the history. So that's quite efficient, and you can do that. But sometimes you say, no, well, I have to really, I come up with a new copy. But well, we are always afraid then to delete that old one, because you never know. Maybe I need it for whatever reason. But do you really need it? I think most of the time, how often do you look back to an older version of a document? Probably not very much. And if you have a need to keep that old version, think about the retention policies. Maybe the retention policy of that old version, you should update that one, because you said, I would like to have this and keep that for 10 years. But then you got the new version. Is that still the 10 years applicable to the old one? Or can you say, well, now you can delete it after a month? If new data is coming in, or if you maybe can clean data, you can also think about, I need some information, and you can aggregate that information. So that's a bit the idea of the enhance phase. Enhancing on itself it has a kind of sustainable aspect in itself, if you do it in the right way. And then the favorite one. Dispose. Throw it away. I'm not sure if you know this lady, Marie Kondo. I think she became very famous on Netflix. She had all kind of good hints and tips and helping people about cleansing, your in terms of housekeeping. And she's really funny. She built a complete business out of that. So that's maybe an opportunity for yourself if you think, what should I do? Well, maybe you can become the Marie Kondo of data. And she has a lot of very nice one-liners. And one of those is, the real problem is that we have far more than we need or even want. Another one-liner of her is, we should be choosing what we want to keep, not what we want to get rid of. Very inspiring lady. I think you can learn a lot from that also when it comes to cleansing your data. First of all, make sure there are retention policies, but you also apply those retention policies. Because I've seen also in a lot in companies, they have these retention policies. They even have this legal obligation to delete it, but still they keep it. But it is important to delete it and also show that you have done so and that you are compliant to the legislation, if that is important for that. And from now and then, run the processes to clean the data, and because that works twofold. It's not only that you need less storage, but it's also that you need less processing, because the next time you do queries or whatever, your data has been cleansed and it goes much quicker. So then kind of the summary in terms of in going with the Marie Kondo in the daily household. The next slide.
Yeah, and I think it also one thing but it's really fun also to do also within your organization is also to participate in the digital cleanup day, or to organize your own digital cleanup day, to really make it a competition also to ensure that people clean up their personal data. And there is always once a year there is a World Digital Cleanup Day. But you can also organize it in another data within your organization. But that is quite fun to do, and you can also add, I would say, a kind of a competition to it. So that's I did it also in the past within Vodafone Ziggo. That's quite fun to do.
Yeah, that's a very good idea. Nice to do. And that makes it a little bit exactly what you say, fun. Because on itself, housekeeping is not fun. At least most of us don't really like it, even though if you so now and then you bring your garbage to where you to the how's it called? Well, we have these locations, right? In if you have a lot of garbage, you go there or you call them and they pick it up for you. And it also sometimes gives a very, very good feeling when you get rid of all the garbage and really clean something. So, but it's like, data and data cleansing and the data lifecycle. It's very comparable, I think, with what we do in our daily life. Yeah, because you would like to buy something. So let's say or people told you that it is important that you have an iPad. So you buy an iPad and then you really start, before you do that, thinking about, okay, what do I need? Sometimes you just would like to go for the latest, the greatest and the most beautiful one. But if you really think about what do I need, how much does it cost? So you really start to consider those things. And then, okay, I have it, I bought it, I use it. And then I have to put it in a place, because when I need it, I have to can pick it up quickly and I would like to use it to kind of to the max. I put apps on it, etc., etc. And then at a certain point in time, you figure out, okay, it's not meeting my needs. Well, it's difficult to upgrade an iPad, but if you have your computer or so, you put some additional memory in it, maybe a new graphic card, and then, but at a certain point in time, it's gone. It doesn't fulfill it need anymore, so you have to get rid of it. And then even when you get rid of it, think about maybe giving it away to organizations that are reusing your equipment again. So and find a new purpose for it. And so that's kind of a bit what you do also, I think, in the terms of data lifecycle management. And it's really all about thinking and applying some best practices around it, which are probably not new, but the fact that you have to really think about it and apply it, I think that is really a good practice, and it can really saves a lot of energy and a lot of storage. I think that's kind of what we would like to share. I see some questions in the chat. Maybe there are other questions as well. Let us go through it. Shall I just read the first one? Compressing data for transport also costs energy. Correct, that's correct. How do we know it's less energy consuming than not compressing it and transporting a somewhat larger data set? Yeah, that's a good question. We discussed that, Pepijn, in our paper as well, that you always have to find this balance, right?
Yeah, indeed, and it depends a lot. For instance, hardware compression or not. So it depends on the situation. What the best thing is to implement. So that is on the art of the architect to look where to go for, but it is something to keep in mind.
Yeah, to add to that, from another perspective, if we store the data, it is by default all the storage efficiency is done on the hardware level, and the efficiency is still in place if we send it and transport it. So we don't dehydrate the data. So the once used efficiency compression techniques, it stays put on the transport as well. So that's the NetAP perspective on that. Not sure how other vendors will do it, but yeah.
But
there is another.
Go ahead, Pepijn.
Oh, sorry, but let's go on. I was already. Then you were not ready.
Okay, so I wanted just to add to that. In terms of the layers, if you do it on a hardware layer, it doesn't make sense to do it on a software layer as well, right? So that's also a thing to be aware. So is it already done? Then don't redo it on another layer.
Yeah.
Yeah. So Pepijn.
Yeah, and there was also a question on the role of AI might play in categorizing black data, so classifying your data. It's been used in catalog solutions currently to classify objects that are harvested in a catalog. So to know, for instance, which type of data is in a database or is stored on an object store. Most of the times, if you use that AI model, you use that once to classify. Sometimes you look at it again to ensure that you have the same data in that same store. It depends on the size of that of the systems you are looking at with those AIs. If that are very big stores, and you think you can gain a lot, but don't know a lot about the data, then most of the times it's worth to look at it. And most of the times you first look at the part of your data with that AI model and not with the whole data set to structure and to classify the data. So then it will have most of the times a positive benefit. Is that answering the question? But
Yeah,
you also need.
Yeah, we do have already some solutions. There is an example from a NetApp solutions where we do this. We use AI to analyze the data, but it's on the infrastructure level, so not on the business level. And it categorizes on privacy items like personal identifiable information, on the total months or years data is not touched anyway, and it could be automated as well. And so there are solutions where AI is used to categorize the data and to get rid of the dark data.
And then there's a question from John de Hoop, a lot about document data storage, but also mindless AI and old broken automation processes will use a lot of his hidden energy. Any thoughts in comparison with document storage? Can you clarify a little bit, Sean?
Yeah, sure. Hello, and thanks for the presentation. There was a lot of talk about storing data and transferring data, like backup data, etc. But what we're coming against, and I thought I read that as well in the energy usage of data centers, is the coming of AI and the mindless use of AI in that topic. And that's not storage as seen as data, but it's just a use of energy that is most of the time is mindless at the moment. That's for the AI part. How do you see that in comparison to what we've seen in the presentation? And the second part of my question is about the automation processes. For instance, if you have your users in a big organization, your users are offboarded. The process of the user isn't completely clean in the Azure side. You've got all those processes checking on MFA and stuff like that. It's all running and running and running, and for one person, one day, it's not that much. But if it's 1,000 persons, 1,000 times a day, it can add up. There should be management on that. But any thoughts on those kind of usages?
Yeah, I think if you look at AI and training of models, and especially there are now also a lot of companies in the world focusing on harvesting data from all over the places to train the models.
Yeah.
And it depends a lot. You need a lot less data when the quality of the data that you use to train your model is higher, because otherwise, if you have hundreds of documents and you train a model and 90% of the documents are right, then you get your neural network it will be trained on the most common commonalities. But if you have less data and you are sure that you know that data and you have the life cycle in the right order, and you know that the data quality is on a decent level, you need to process less data to get to the same outcome. I think so. That is one of the things how I look at it.
Okay.
So it's all, if you look at also that data lifecycle management, if you do it well, if you structure well, if you have the right metadata attached to the data, then you know more, so you will have a higher level of the quality. For instance, if you look at the document, you see that a lot now with AI, that knowledge bases are becoming a very important source of AI models, and most of the times people did not look at document stores as input for AI, and then you see that all kind of snippets of documents are used that are old and not the most recent document anymore, and then you get real unexpected outcomes from the models, and that's so you have then. You're running a model and have unexpected outcomes. So also the quality of the outcome is low, the value of the model is low, and all the things that you did to enable and to implement that model are waste. Also from from value perspective, but also from energy.
Mm-hmm. So yeah, okay. It's all about data quality as well. So yeah, I think it helps with each other. Okay.
Yeah,
Well,
I think the principles from this white paper are well applied to that as well, right? So yeah.
Shall I take the next question? It's from Patrick. Any principles around the energy consuming AI solutions? Our focus clearly of this paper is really on the data lifecycle. Having said that, definitely we can say something about AI solutions. There are, I think, I always look at it from two angles. So it's either using AI models, so there's the inference part, or training models. And then it's also, when we're talking about AI nowadays, is a lot of times talking about large language models, but we have still all these other AI also. But it's especially, I think, the large language models that are so energy consuming. And I think there are indeed some principles around it. So try to train it with as less data as possible and use small models. That's also a good practice, and use therefore models which have a specific purpose. So the disadvantage of the generic large language models are they are large, and it's better to train the model for a specific purpose, so your model stays small, and it also will meet the same results in terms of quality with less energy. So as IBM, we have recently delivered Granite 3, and there's within that Granite models, there is a lot of focus on making the models smaller and smaller and smaller. It's again smaller than 2, sorry, and it should be, in terms of quality, it should be better.
Yeah, and I think also if you look at machine learning from an AI perspective, then more the classic AI, then also the types of codes that you use apply. For instance, if you use AI for embedded devices, for instance, then it's better to use C++ for your model than Python in most of the cases. So yeah, it's also there, the generic coding principles apply, but yeah, we also know that most of the data scientists currently use Python and not C++ anymore.
Any other questions or remarks? The paper link, maybe we can share that.
Yeah, share my screen again.
So here is the link. You can find it on the NCDD.
Are you going to put it in the chat? Otherwise, I do it. Can someone?
Yes, I also want to announce the winner of the pub quiz.
Yeah.
Wel, tromgeroffel. Thomas de Ruiter van Ilionix heeft het boek gewonnen. He won the book. He had 30 points of the total 60. Some other had 30 as well, but he was the fastest. So that is measured as well. So Thomas will take contact with you by email and make sure that you receive the book. Yes?
Congratulations.
Congratulations.
Thanks a lot.
Well, yeah, so if there are no further questions, then I would like to thank our speakers very much for their insights they shared today with us. For everybody who isn't a participant in a coalition yet, please check out the website, and we're really looking forward to welcome you as a participant, since this presentation is about one of the deliverables from the working groups of the coalition. So we're very proud of that. Yeah, thank you so much. And then I hope to see you soon at one of our events. Also check out the Jaarfestival from ACP. It's this Thursday. Still places available, so hope to see you there.